Alright, this section is 1.3, which is limits analytically. There's a lot of stuff in this section, so I decided to split it up into two different parts. Analytically just means we're going to find the limits by hand. We're not going to rely on a graph anymore. We're going to kind of just work with a given function and find its specific limits. This section begins with some properties of limits. I'll go ahead and give you a moment to pause it, copy these down, and then I'll talk a little bit about each one of them. You have to start off with the idea that they give you information, or you're able to find particular limits about f of x and then g of x. And they're going to give you the limit, let's say, for this one equals L, and the limit over here, let's say, equals K. And the first property says that if you have C, which is a constant, times the function, you can just multiply the constant times the limit. For example, if this limit, let's say, is 7, and this constant is 3, then the answer is going to be 7 times 3. Property number 2 says that if you're adding or subtracting two separate functions, you could add or subtract their answers. Property number 3 says somewhat similar, that if you're multiplying two separate functions, then you can multiply their individual limits. And then property 4 goes along with that as well, that if you're dividing two functions, then you can divide their individual limits up here, provided that the denominator k does not equal 0. So whatever is down over here, that limit cannot equal 0, because as we all know, we can't divide by 0. Alright, so let's go over some examples that use these. Let's go over an example that uses these properties. You start off with the limit approaching 3 for both f and for g. You're given the fact that f of x has a limit equal to -4. The limit for g is equal to 5. So for part A, you're looking at the limit approaching 3 of 2 times f of x plus 3 times g of x. So the first example, for part A, kind of uses two properties at the same time. It uses the fact that I can multiply by a constant and the fact that I can add individual limits together. So what this means is that I can take 2, and I know the limit of f of x is -4, so I can go -4 plus I can go 3, and I'm given that the limit is equal to 5, and then just simplify this to get my answer. This is going to be -8 plus 15. -8 plus 15 is going to give me my answer to be 7. For part B, I'm multiplying individual functions, which limit property number 3 states that if I'm multiplying, I can just multiply individual limit answers. So this is just going to be -4 multiplied by 5, which gives me -20. And the last part C says if I'm dividing f over g, but now I'm multiplying it by 2, so I've got to take the limit of f, which is -4, and then take 2 times the limit of g, which is 5. So my answer over here is going to be -4 divided by 10. We reduce this as -2 over 5. Okay, so that's the example 1 using limit properties. Example 2 now is we're going to be looking at some limits from piecewise functions. Again, we're not looking at a graph anymore. We're looking at just what a function is given to us, and in this case, it's 3 separate definitions before you get to -1, in between -1 and 2. And then after you get past 2, you have this bottom definition. Alright. There is 2 parts. Part A is going to be finding the limit as x is approaching -1. Well, if you recall from the very first video, the introduction to limits, for this limit to exist, you have to have both sides equal to each other, meaning that the limit from the left has to equal the limit from the right at the point. in this case at -1. So what this really means is I have to find the limit as x is approaching -1 from the left of h of x, and then find the limit as x is approaching -1 from the right of f of x. If these two are the same values, then the limit exists. If they're different values, then you would say the limit does not exist, and that'd be it. If I'm approaching -1 from the left, that's going to be the top definition, all the things that are to the left of -1. So that means I get to plug in -1 squared plus 2 to give me an answer of 3. -1 from the right, that's a little bit past -1, but then going back towards from the right. So it's going to be plugging it into the middle. It's going to be 7 times -1 plus 10, which gives me -7 plus 10, which gives me 3 as well. So these two meet up at the exact same point, so they both equal 3. So I can say that my limit is equal to 3. Part B is going to be finding the limit at the other point that they split, which is at 2. I take the exact same approach. I have to find the limit as I approach 2 from both sides, the left and the right. So this is going to be the limit from the left. In this case, the limit from the left is going to be the things before I get to 2. So it's going to be using this one in the middle. So it's going to be 7 times 2 plus 10, which gives me 14 plus 10, which is 24. Now on this side, if I approach the limit from the right, so all the things that are past 2, that's going to be the bottom definition. A little bit past 2 coming in from the right, it's going to be the bottom definition. It's going to be 2 minus 3 quantity squared. This is going to give me -1, and if I square -1, I end up with +1. And as you can clearly see, these numbers are not the same. It's not going to be the same limit. So this limit over here would say does not exist, and that's the answer.